Hi class, today we're looking at Chapter 6, Lesson 4, Exponents and Division. So nanorobots are microscopic machines that may soon be used to fight illness inside the human body. When working with very small numbers, such as the length of a nanorobot, you often divide expressions with exponents. So you can divide powers with the same base by writing all the factors. So if we had 7 to the 5th power divided by 7 to the 3rd power, it's like saying this: 7 times 7 times 7 times 7 times 7 divided by 7 times 7 times 7. So we can go ahead and cross out. If we cross out this one on top, we cross that on the bottom. So then we're left with 7 to the 2nd power over 1. And we can drop the 1 and just do 7 to the 2nd power. So dividing powers with the same base. The same, I showed you how to do it the long way. The same thing would have been if we were to have said 7 to the 5th power minus the 3rd power equals 7 to the 2nd power, right? We get the same thing. So down here, you'll see that if we had 8 to the 5th power and divided by 8 to the 3rd power, it's just like subtracting them. We get 8 to the 2nd power. If you are not using numbers, if we're looking at it algebraically, we have a to the m power divided by a to the n power equals a to the m minus n power. Okay, so now let's look at dividing powers. So write m to the 12th divided by m to the 2nd using a single exponent. So what we would do is we would write m to the 12th minus 5th equals m to the 7th. Piece of cake, just like that. That's your answer. You go ahead and try this next one. Come back to me when you're done. Okay, so you should have got w to the 3rd power as your answer. So now we need to look at 0 as an exponent. So if you see that it says for any non-zero a equals to the 0 power, that equals 1. So therefore 9 to the 0 power also equals 1. And so let's look at why that's the case. So if we have 3 to the 5th power, that's like saying 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. And remember, we can cross them out. Those two, those two, those two, those two, those two. So that's like saying 1 over 1. So therefore, it equals 1. And if we were to subtract them, if we had 3, 5 minus 5, that equals 3 to the 0 power, that we know just equals 1. Something you might have to memorize. So let's look at simplifying these. So if we have negative 8 to the 0 power, that equals 1. 3m to the 0 power. Okay, so if there were parentheses around this, then that would equal 1. But because there are not parentheses, this is like saying 3 times m to the 0 power. M to the 0 power is 1. So then it's like 3 times 1. So your answer to this one equals 3. Okay, so be aware of those parentheses. this next one where you will try it will challenge you in that respect. Press pause, do these 3 on your own, come back to me when you're done. Okay, so this first one you should have got, oops, wrong thing, should have got 1. The second one, 1, because this whole thing here is looped together. C, you should have got 2 as your answer, because this r to the 0 equals 1. And then you had to multiply that times 2. Therefore, you end up with 2. Okay, so now let's look at negative exponents. So for any non-zero number, a, and integer n, so a to the negative first power, is like saying that equals 1 divided by a to the n. Okay? So let's get a little bit of a clearer understanding of that. If we look at this example down here, this is like saying 6 times 6, and this is like 6 times 6 times 6. These get crossed out, so that equals 1, 1, 1, 1. And so then we have just a straight 6 down here. So this is like saying 1 over 6. But let's take a look at if you were to subtract the exponents. So if it would have been 6, 2 minus 3, then that would equal 6 to the negative first. So this same thing, 1 over 6, anytime you have that on the bottom, you can flip it up to the top as long as you make it negative. So that equals 6 to the first power. So let's take a look at these to try to clear that understanding up. So the same thing, 3 to the negative second power, is like saying 1 to the 3 over 3 to the positive 2 power. Okay? And then this next one, we can, same thing, we're just going to flip it to the bottom, so it's going to be 1 over y to the positive 6 power. Okay, so if it's a negative, that's just the way that you can write it, is to make it so that it equals a positive, is to turn it into a fraction. Okay, so why don't you please try these 3 on your own? Come back to me when you're done. Okay, so you should have got 1/3 for the first one. When you flip it, it does equal 1 to the third to the first power, but you don't need to leave that first power. Go ahead and drop that and just get 1/3. The next one, you should get 1 over w to the fourth power. And then this last one was a little more tricky. So when you're flipping it, you really are only turning the exponent into a positive. And so once I did that, I did 1 over negative 2 to the third power. That's like saying negative 2 times negative 2 times negative 2, which equals a negative 8. So therefore, my answer is going to be negative 1/8. So there is more than one way to do this. Let's look at these two methods. So when we're looking at simplifying the expression 4 to the third power times 4 to the negative fifth power, Tina's method is that she uses a positive exponent. So first she takes them and turns the second one into a positive, and then multiplies the factors together, subtracts the exponents with the same base, simplifies, and then uses a positive exponent, and then has to simplify again, so she gets 1/16. However, Eric says instead of doing those added steps, he can just add the exponents. So he adds the exponents, 4 to the third power plus a -5, which equals 4 to the negative second power. He then uses a positive exponent and simplifies. He gets the same answer. So I want you to choose what method you would prefer and try to solve this one. 5 to the second power times 5 to the negative fifth power. Press pause, come back to me when you're done. Okay, so you should have got 1 over 125. This side over here was more of what Tina did. So I flipped them and then combined the terms and then subtracted and got 5 to the negative third, made that into a positive exponent, and then solved 5 to the third power. And then over here I used Eric's method, and I just added 5 to the second power plus -5 and got 5 to the negative third power, and that is the same step right there. So either way is correct. Eric's is a little bit shorter, less steps, but it is a little bit more confusing adding them. So your homework for tonight is going to be page 147, number 3 through 21 odd. Happy homeworking!